We will now be learning how to determine the relative masses of isotopes by using mass spectrometry. This is a technique that involves the usage of an instrument called a mass spectrometer. We know that every instrument serves a purpose, right? In this case, this instrument aims to measure the exact mass of different isotopes of an element. This brings up the next question. Do you want to know how this instrument functions? Basically, what happens is a substance that can be a solid, liquid or gas is first vaporized and then ionized by the bombardment of high energy electrons. What do you think will be the result of this bombardment? This bombardment causes these gaseous atoms of elements which are used as a sample to break down into its charged particles. As their valence electrons gets knocked off to form cations, these ions are separated according to their mass to charge ratio, m/e. Following this, each type of ion is detected by a detector and then displayed in the form of peaks on screen. Finally, this data is recorded on a graph with the mass to charge ratio on the x-axis, also called abscissa, and the relative abundance of ions on the y-axis, also called ordinate. This entire process takes place in the mass spectrometer, and this graph or plot is called the mass spectrum. It is also known as Aston's mass spectrograph, which was designed to identify the isotopes of an element on the basis of their atomic masses of these isotopes. After getting an idea about the operation of this device, we can certainly acknowledge its importance, isn't it? If not now, I am sure by the end of this video, you will be able to do so. Do you know, there was another instrument designed like the mass spectrometer called Dempster's mass spectrometer. It was used for the identification of elements in their solid states.